Implementing IAM S3 DynamoDB with Terraform. Streamline your cloud setup with IAM S3 and DynamoDB integration in Amazon Web Service. In the era of cloud computing, efficiently managing infrastructure is crucial for developers and organizations. Terraform, an open-source infrastructure as code EAC tool developed by HashiCorp, enables teams to define and provision cloud infrastructure using a high-level configuration language. This guide explores how to implement key AWS services, identity and access management, IAM, simple storage service, S3 and DynamoDB using Terraform, automating and streamlining the process to ensure secure, scalable and reliable cloud environments. Why Terraform and for AWS services? Terraform's declarative configuration language allows you to describe your desired infrastructure state, and it takes care of reaching that state with minimal human intervention. It supports numerous providers, including AWS, making it an ideal choice for setting up and managing AWS resources like IAM, S3, and DynamoDB. Terraform's ability to manage the entire lifecycle of resources, including creation, modification, and deletion, ensure infrastructure can evolve safely and efficiently over time. Implementing IAM with Terraform. Identity and access management, IAM, is a cornerstone for AWS, allowing you to securely control access to AWS resources. Using Terraform to manage IAM can help you automate the creation of users, group, roles, and policies, ensuring consistent and secure access control. Welcome to my source code. I already defined one provider, AWS, and specify the region US West 2. Now, let's define together one resource, AWS IAM user, in my case defining the example user, and binding with the name, in my case will be example-user. Okay. Now let me define a group, in this case will be like AWS underscore IAM underscore group, and the name will be example underscore group. In this case, don't confuse the name of the user group with the name of a resource. So the name of a group will be, for example-group. So this is the name of a resource that should exist on AWS console. Okay, now let's create a membership. Let's concatenate one to each other. Okay, first of all, let's create a resource, AWS IAM group membership, and the name will be example underscore membership. Okay, let's define a name for this membership. In my case will be example-membership. The name needs to be meaningful and significant to you, and that is connecting a list of users. In my case will be only one user, that will be AWS IAM user.example user, and let's specify the name, so will be .name. Here we go. Perfect. And we can also add other users to this list, and on the group, let's specify the name of a group. So AWS IAM group example group.name. Great. In this way, we associate a list of users to a group. For example, define an IAM user, an IAM group, and adds the user to the group, showcasing how straightforward it is to manage IAM entities with Terraform. Implementing S3 with Terraform. Amazon S3 provides scalable object storage suitable for storing and retrieving any amount of data. With Terraform, you can automate the creation of S3 buckets, set up policies, and configure other settings to manage data efficiently. Let's define now one Terraform S3 bucket. Okay, let's create a resource. It will be the type of AWS S3 bucket. And let me define as well also a name for this bucket. Let's follow the same style as before, so let's use example_bucket for name. Okay, let's define some few properties of this bucket. First of all, let's define the bucket name under the bucket parameter. So it will be my-example-bucket. And let's define the ACL. ACL is an access control list. In this case, let's define that it is a private. So nobody else apart from us can access this data. Let's define some tags. For example, a name that will be memorable for us and environment. The name could be like a development or something more fancy. Let's start with development. And the environment is very useful to differentiate between development, staging, and production, for example. In this case, let me set up a bucket for development. Okay, a memorable name might be a little bit meaningful, like my example bucket, or exactly what it's going to contain. This configuration creates a new S3 bucket with a set of predefined tags, illustrating the ease of provisioning storage resources with Terraform. Implementing DynamoDB with Terraform. DynamoDB is a fully managed NoSQL database service that provides fast and predictable performance. Terraform can be used to create and configure DynamoDB tables, including settings for through-output encryption and more. Now let's define together a DynamoDB resource. The resource will be AWS_DynamoDB_table, and let's name accordingly to the others example_table. Okay, this type of resource has plenty of different properties. I believe that the most important one are, okay, of course, we start with a name that will be example-table. Feel free to customize with a real example meaningful for you. The building mode will be provisioned, and let's define also read capacity of 10 and write capacity of 10. Hash key, let's define ID and some attribute. Name will be the ID and the type will be a string. Okay, now some tags to quickly identify our resource in AWS. Name, my example table, and environment development, same as the S3 bucket. This example demonstrates creating a DynamoDB table with specific through-output setting and attributes, showcasing Terraform's capability to manage database resources. Best practices for using Terraform with AWS. Version control. Store your Terraform configuration in a version control system to track changes and collaborate with your team. Modularize your configuration. Organize your Terraform configurations into modules for reusable and maintainable code. State management. Use remote backends like AWS S3 for Terraform state file to enhance collaboration and state locking. Review and apply changes carefully. Always use Terraform plan to review changes before applying them with Terraform apply to avoid unintended modifications. In conclusion, leveraging Terraform to implement and manage IAM, S3 and DynamoDB on AWS not only streamline the deployment process, but also enhance the security, scalability and reliability of your cloud infrastructure. By embarking infrastructure as code, teams can achieve greater efficiency and consistency in the cloud environments, paving the way for more innovative and resilient applications.